Welcome to today's GATE session. My name is Naveen Kumar, Assistant Professor, Department of Artificial and Data Science, S.A. Engineering College. Today's topic was I am going to take CART algorithm from machine learning. First of all, we want to know what is meant by CART algorithm. It was introduced by Stone, Friedman and also invented the first CART version of an algorithm at 1984 itself. The official publication with the CART decision tree software, it was a revolution in the world of algorithm. To construct a decision tree, any decision tree, the CART algorithm will be used. CART is one of the most methods for decision tree and data analytics. In a data analytics, if you want to analyze any data, CART one is used for most useful methods of decision tree. It refers the following types of decision tree. First one is classification decision tree and next one is regression decision trees. Classification decision tree means when the target variable is continuous, the tree is used to find the class into which target variable is most likely to be fall. The regression tree that is used to forecast the value of a continuous variable. If any action will be continuous, it will go for a regression trees. The representation used for CART is a binary tree. Any representation of the CART algorithm will be used as a binary tree. Stopping criteria define how much tree learns and pruning can be used to improve learn the trees. If you want to learn the trees, you have to prune the unwanted data things. For this one is the stopping criteria will be used. Predictions are made with CART by traversing the binary tree given in a new input vector. If you want to predict any value, it will be used for new input records. The tree is learned using greedy algorithm on training data to pick splits in the trees. Next one is about CART algorithm. The nodes split into subnodes in the basis of threshold value of an attribute. If you have any tree, each and every data will be an attribute. For example, height is one of the attribute and male and female is the another attribute. By using that, we have to predict the values. The searching will be happens in a homogeneity of subnodes with the help of Gini index. Gini index means the value of an attribute. Which one takes the best value? 0 is considered as best one in CART algorithm. First one is about greedy algorithm. The input variable splits points selected through the greedy algorithm. The input variables are splitted by using a greedy algorithm. Next one is about stopping criteria in splitting method. By which attribute, which one is splitted as a tree. That next one is about pruning. That doesn't find number of splits in the trees. Only leaf nodes are eliminated in a total cost function for complete test set decreases. Next one we go for a simple example. We are having a table with attribute outlook, temperature, humidity, wind and decision. By using this table, we are going to construct a decision tree. First one we have to calculate the Gini index for CART algorithm. Gini index is nothing but the metric of classification task in a CART. It stores sum of squared probabilities of each class, that means each attributes. Gini formulas is equal to 1 minus summation of probability of square for I is equal to 1 to number of classes we are having in a table. We are having total number of 5 classes in the table and also we are having a decision one. This is the simple outlook. Consider this table. We are having a first column as outlook, next one is temperature, next one is humidity, next one is wind. By using these 4 attributes, the decision will be taken. We have to construct the decision tree for these attributes. First we will take the outlook. Outlook we are having 3 options, that means sunny, overcast and rain. If yes value, the decision is yes. If your wind rises, that means number of metrics. sun is S2, overcast S is 4 and rain is 3 and no is 3, 0 and 2. If the total number of instance for sunny means 5, that means total value of yes and no. 5, 4, 5. This total will be 14. Then by using this one, we have to calculate the attribute and then what's happening, outlook. For example, Gini of outlook equal to sunny means 1 minus summation means we have to add two things. Here yes and no is the option is there. 1 minus 2 divided by total number of instance whole square minus no divided by total number of instance whole square. We have to calculate the value means we will get the value of 0.48. If outlook equal to forecast, we will get the value of 0 because the total number of overcast is yes, and then 1 minus 4 by 4 whole square in 0 by 4 whole square means you will get the value of an 0. If Gini outlook equal to rain, then you will get the value of 0.48. Then we have to calculate the weighted sum of Gini index for outlook future. For example, for this attribute we have to calculate the weighted sum of Gini index. For this one the formula will be total number of instances, that means number of instances for each attribute divided by total number of instances, that means 14 into Gini index of this attribute, this value. That means by summing all the things you will get the value of 0.42. The next one like that we have to calculate the same value of a temperature also. That means temperature we are having three classes: hot, cool and mild. But we have to calculate the Gini for temperature equal to hot. Then we have to calculate the Gini for cooled and then mild. Then the total number of instances will be 14 here. That means you will get the value of temperature equal to hot means 0.45 and temperature equal to cool means 0.375 and temperature equal to mild means you will get the value of 0.445. We'll count the weighted sum, you will get the value of 0.439. Like that we have to calculate the value for humidity, weighted humidity future, sum of weighted humidity future. For humidity you will get the value of 0.367 and then wind you will get the value of 0.428. Then we go for an time for decision of a decision tree. That means we have to calculate for the outlook. You have the Gini index of 0. Sum of weighted Gini index is equal to 0.342, temperature 439, humidity 0.369, wind 0.428. Like that we have to decide time to decide. That means the Gini index value will be lesser when compared to all other things. By comparing this one and this one value will be less. So this will be considered as topmost node of an decision tree. Like this we have to, from the outlook we are having an three parts. First one is sunny. From these things we will get the value, then overcast, then rain. For example, for the overcast all the decision will be yes. That means no need to go for this table, we can construct the decision tree as yes itself. Then we have to we have to calculate the Gini index for sunny and rain. For example, sunny we are having that table. We are having the temperature of hot, mild and cold. For that we have to calculate the Gini index. That means temperature equal to sunny and temperature equal to hot. Sunny, temperature equal to hot. Next one, sunny, temperature equal to cold. And next one, sunny, temperature equal to mild. For this one you have calculated the, you know the instance, how much instance we are having hot, how much instance is there. That means 1, 2 and 3. Sorry, 1 and 2. And next one cold means 1. And then mild you are having 1 and 2. So the total number of instance will be 5. From the previous slide we have to calculate the Gini index. Next one, we have to calculate the Gini index for humidity also by using the previous table. That means humidity means high and normal. We are having two classes. For that one we have to calculate the Gini index. Then wind also, we have to consider the wind by using wind. Weak and strong we are having, yes and no we are the decision variables. So the number of instance we are having, you are able to calculate the sum of weighted Gini index. From this one we are having the Gini index value. That means the temperature is, the total weight of temperature will be 0.2, and then the total weight of humidity will be 0 and wind will be 0.466. So from this one if you calculate it, consider the lowest value will be humidity. From this one we have to take, from this one we have to subdivide the two values. From the humidity we are having, what is having? From the humidity we are having two things, high and normal. From that one humidity will divide us two tables as, from this outlook we are having sunny because of humidity. From humidity we are having low and high values. Here no and then yes. That means humidity subdivided into two parts, full is no and full is yes. So we can go like this one, humidity, this one. We are having another table as rain. Like that the humidity we have to consider and we have to calculate the Gini index. That means rain temperature, rain humidity, rain wind. From that one we will get the sum of weighted Gini index. For Gini temperature of rain and outlook, rain and temperature, from the outlook rain and temperature equal to cold. You are having the temperature of cold, mild and thing. That means you will get the value of total thing will be 0.446, here 0.446, and then rain you will get the value of 0.466. That means the decision of rain outlook will be temperature 0.466, humidity 0.466 and wind will be 0. That means the lowest value will be wind. Wind will be having, that means wind will be separated into weak and strong categories. From the weak there is a yes and from the strong there is a no. That means if you draw the decision tree for this table you will get this like, from the outlook it will be separated into sunny and rain. The overcast will be always yes. From sunny it will be subdivided into, from sunny because of humidity it will be divided into high and normal. Here rain will happens when wind will be strong or weak. If it is a weak wind the rain will be possibilities. If it is a strong wind there is a no rain. This is like we have to find out the decision tree by using a CART algorithm. Let's see some of the gate example questions in CART algorithm. For example, if you want to calculate the Gini index for a node will be given will be We already know that we already studied about how to calculate the Gini index. That means the formula will be 1 minus summation of pi whole square. All these things will be wrong. We already studied the formula directly. And then the next one will be a node contains 10 samples and 6 belongs to a class A and 4 belongs to class B. Compute the Gini index of this node. That means we are having a total value of how much instances? 10 instances. Correct? That means 10 instances. S will be 6 and no will be from A value will be 6 and B value will be 4. If you calculate that means you will get the value of 1 minus summation of P A whole square, and then that means you are having the total value will be 10 and then A is equal to 6 and B is equal to 4. By using this one you have to calculate the value of Gini index of a node. We already know that by calculating the Gini index the value will be 1 minus summation of Pi whole square. That means 1 minus P1 whole square plus P2 square. That means we are having the value of class A and B. That means two values. The total number of instances will be 10. That means 1 minus 6 by 10 whole square plus 4 by 10 whole square. From this one if you calculate it means 1 minus 0.6 whole square plus 0.4 whole square. That means you will get the value of, by calculating this value you will get 0.36 and 0.16. Then you will get the value of 0.48. For example, for this node you will get the Gini index value of 0.48. That's all about the CART algorithm and some of the gate questions. We will see the remaining algorithms in next class.